Hi, welcome back. I'm John, and this is video 3 of our SPSS tutorial. In today's video, we'll dive deeper into descriptive statistics and learn how to standardize data using z-scores. Previously, we covered how to create variables, enter data, and calculate measures like the mean and standard deviation. Now we'll use some more tools to add to your SPSS skill set. So let's continue from the data set that we've been working on. To start, we'll generate some additional descriptive statistics. And so follow along, we'll go to Analyze, Descriptive Statistics, and then Descriptives. Now, when the window opens, by default, all of these variables will be or appear in this left-hand box. And I'm going to then move over all of the variables except for the random ID number, since that isn't relevant for this analysis. Again, I can click and use the arrows, or I can drag and drop. Now click Options, and you'll see some important stats like the mean and standard deviation are already checked. That gives critical information about the central tendency and the spread of the data. There are also other options you can check, such as the range or the sum, but we'll leave those unchecked for now. So click Continue. And then click OK to generate the output. So first, notice the valid listwise line, which shows the number of complete cases without any missing data. So this tells you how many valid responses you have for each variable. For categorical variables like gender, you can see that the minimum value is 1 and the maximum value is 2. And those represent the codes used to indicate male and female. However, the mean and standard deviation for gender don't provide meaningful insights because gender is categorical and not numerical. So you can ignore that. Now shift your attention to the weight variable with 10 valid cases. And the mean of weight for our participants is 133 pounds. That's the mean. 133 pounds. And the standard deviation is 13.4 pounds. This means that most people in the data set fall within a range of about 13.4 pounds above or below the average of 133. Similarly, I can interpret that for height and say that on average, our participants measured 65.8 inches, and most of the participants fell either above 2.39 above or 2.39 inches below the average of 65.8. Now that we've generated some basic descriptives, let's go deeper. There's another method in SPSS that gives you even more details and visualization options. So we're going to use the explore function. So to use that, go to Analyze, Descriptives, and then to the Explore tab. Again, by default, all of these variables will appear in the left-hand box. And so this time we'll move over height and weight variables just to the dependent list. We'll play with the factor list in a second. But for right now, just height and weight variables moved over to the dependent list. Now I'm going to click on stats or statistics. And we're going to check the boxes for outliers and percentiles. Normally those would be unchecked, but I've already gone and kind of done some analyses. So if they are unchecked, which they should be by default, go ahead and check them. And this will allow us to see any extreme values and how the data is distributed across different percentiles. So after selecting those, click continue. Next, we'll go to plots and check the option for histograms. Once you've done that, click continue, and then we'll click OK to generate the output. In the output window, you'll notice there's a lot of info, and we can see detailed descriptive statistics, including percentiles. So for example, if we look at the 50th percentile, that's the median value or the middle point of the data. You can also spot outliers, which are values that fall significantly outside of the normal range. And these are flagged automatically in the output. So as we continue to scroll down further, you'll see a histogram for each variable. This is a great way to visually check the distribution of the data. For instance, if the histogram for weight shows a normal bell curve, that means most participants' weights are clustered around the average or the mean. And looking at it, does it look normally distributed? And for weight, I would say no. I would say that this data is skewed. If we look back at the histogram for height, it appears to have a little bit more of a normal distribution, with the peak occurring in the middle. And so I would say that the data for height is at this point I could say it's definitely more normally distributed than the data for weight. So let's again take it a step further, and we're going to split our analysis by a categorical variable, in this case gender. And this will allow us to see how the stats differ between males and females. To do this, I'm going to go to Analyze, Descriptive Stats, Explore. And keep height and weight variables in the dependent list. But now I'm going to move gender to the factor list. And this will divide the data by gender. So click OK to run the analysis. The output now shows separate descriptives by gender. You'll see separate means and standard deviations for both males and females. For example, the mean weight for females might differ slightly than that of males. And that could be useful if you want to compare different groups within your data. Look further and you'll see that the box plots for each group are now displayed side by side. Box plots visually display the spread of the data and highlight any outliers. You'll also notice separate histograms for each group. And this really makes it easy to compare the distributions. Next, let's talk about z-scores. Z-scores standardize data, and it's a helpful way of comparing values across different variables or data sets. To generate z-scores, we're going to go to Analyze, Descriptive Stats, and Descriptives again. This time, remove any categorical variables like gender from the analysis. Since z-scores apply to continuous data only. And at the bottom of the window, you'll see a checkbox that says Save Standardized Values as Variables. Check that box and then click OK. Once the analysis is complete, we'll go back to your data view in the data editor window. And in data view, you'll now see two new columns, Z height and Z weight. These represent the z-scores for each individual's height and weight. And z-scores tell us how many standard deviations a value is from the mean. For example, if someone has a z-score of plus 1.5 for height, that means their height is 1.5 standard deviations above the average height. Similarly, a z-score of -1 for weight means that their weight is 1 standard deviation below the mean. So take a second and we'll look at the z-scores in the data set. So participant 1, a male with a height of 64 inches, is -0.75 standard deviations below the mean. So under average for height. For weight, at 128 pounds, a z-score of -0.37, we'll round that to 0.4 and say that this participant or this participant's weight was -0.4 standard deviations below the mean, or underweight compared to the mean. And so that's how you would generate and interpret z-scores in SPSS. The z-scores provide a standardized way to compare data points within a data set. It makes it easier to identify how far values deviate from the mean. And in the next video, we will talk about correlations and examining relationships between different variables.